One of the natural wonders of the world is the largest monolith or rock located in Central Australia. It is called Uluru or Ayers Rock and belongs to the Aboriginal people of Australia. This solid monolith is made of sedimentary rock and is the size of 11 football fields. Ayers Rock was a part of the ocean floor some 500 million years ago, and as time progressed, layers of sediment began forming this rock. Once the ocean receded, the rock was exposed and has been eroding into what you see now. Depending on the time of day, Ayers Rock can dramatically change colors from blue to glowing reds. Welcome to the Rock Cycle video quiz. My name is Jewel, and today we're going to learn about the rock cycle. We will cover the layers of the earth, the three types of rocks, igneous, sedimentary, and metamorphic. And finally, you will learn how the rock cycle incorporates those rocks in the rock cycle. As we learn about the rock cycle, some of my friends will pop in from time to time to ask you some quick quiz questions. Don't worry, all the answers are in the video. Just remember to write down your answers so you can check how well you did at the end of the presentation. Let's get started. Just like a snake has to change its outer skin, the Earth uses the rock cycle to change its skin over millions of years. The rock cycle slowly churns rocks using heat and pressure, removing the old rocks and replacing them with new ones. In order to understand where rocks come from and how the rock cycle works, you will need to understand the structural makeup of the Earth. Try to picture an avocado. Inside an avocado is a large seed. Surrounding the seed is the green squishy fruit, and covering the fruit is its outer skin. The Earth is very similar. It has a large iron center, a semi-liquid mantle or layer, and an outer covering called the crust. Let's start at the center and make our way outward. At the center is the iron core, which has two layers, the inner and outer core. The solid inner core is about the size of the moon and is made mostly of iron. The outer core is also made of iron, but is not as solid like the inner core. It's a slow churning sea of iron. The outer core generates more heat than the inner core. It is the movement of this massive sea of iron that produces the magnetic field around the Earth. The next layer is the mantle, which makes up 70% of the Earth. It is made of solid rock, which churns slowly like wet cement. This is where rocks are altered by heat and pressure. The final layer is the outer skin, or crust. The crust has different thicknesses throughout the Earth. Underneath the ocean is the oceanic crust and has an average thickness of 4 miles. The crust underneath the continents is called the continental crust and is much thicker at an average of 22 miles. All right. It's time to quiz you on the information you have just learned. Pay attention and write down your answers. Good luck.
Question 1. Which part of Earth's structure is about the size of the moon? A. Crust, B. Mantle, C. Outer core, or D. Inner core? Question 2. The outer core is a sea of iron which produces what? A. The ozone layer around Earth, B. Carbon dioxide for plants, C. Magnetic field around Earth, or D. Oxygen for animals to breathe? Question 3. The blank makes up 70% of the Earth's structure. A. Crust, B. Mantle, C. Inner core, or D. Oceanic crust? Question 4. The blank is located underneath the continents and has an average thickness of 22 miles. A. Oceanic crust. B. Island crust. C. Bread crust. Or D. Continental crust.
How'd you do? Did you get all the questions correct? Good. Let's move on to igneous rocks. Igneous comes from the Latin root ignis, meaning fire. Deep inside the mantle, heat and pressure form igneous rocks from magma. Magma is rock in a liquid state that has pressurized gases that are trapped inside. When the pressure builds up, the gases start to creep their way upwards towards the crust, carrying the magma along with it. Once the gases find a fissure or crack in the Earth's crust, the gas and magma escape, causing a volcanic eruption. The more pressure that builds up, the more violent the eruption. Once magma reaches the surface, it is called lava. The majority of igneous rocks begin to cool and harden once on the surface, but some igneous rocks never make it to the surface and they cool and harden deep in the crust. This cooling effect allows the formation of one of nature's most beautiful creations, crystals. Let's visit a good friend of mine, Roy Schieser, who is a geologist and can tell us more about igneous rocks. Hey, Roy.
This is a piece of granite. Granite is an example of igneous rock, one of the three rock types in the rock cycle, those being igneous, sedimentary, and metamorphic. If you look closely inside of an igneous rock, you'll find that it is made up of a bunch of interlocking crystals of various minerals. This specimen, which is actually a geode, have larger crystals which are visible to the naked eye. These crystals are evidence of atoms being arranged in an orderly fashion. This particular mineral is called quartz, which makes up a good deal of what's inside this specimen. Now, igneous rocks come in two different types. Those rocks which have crystal grains that are visible to the naked eye, and then those types of igneous rocks which have a smooth texture where the crystals are too small to see. The size of the crystals is evidence of whether or not the rock cooled underground or above ground.
Thanks, Roy. Okay, don't forget how igneous rocks are formed because later on we're going to learn about the rock cycle and igneous rocks are an important part of that. Okay, my friends are back and are ready to quiz you with 4 more quick quiz questions. Don't forget to write down the answers. Good luck.
Question 5. Igneous comes from the Latin root ignis, which means A. Water, B. Fire, C. Air, or D. Ice. Question 6. Blank is what helps the magma reach the surface. A. Gravity, B. A pump, C. Pressurized gas, or D. Gravitational pull of the moon. Question 7. True or false? The more pressure the gas is under, the less violent the eruption. Question 8. When igneous rocks cool underground, they form A. Crystals, B. Deep colors, C. Petrified wood, or D. Gases.
Sedimentary rocks are made from sediments or deposits of other rocks. Once rocks make their way to the surface, they are exposed to erosion caused by weathering, which breaks them down. There are 2 types of weathering, mechanical weathering and chemical weathering. Mechanical weathering strikes at the structure of the rock. The continual actions of ice, wind, frost, and plant roots help break larger rocks into smaller rocks. Chemical weathering attacks the rock's chemical makeup rather than its structure. Rainwater and carbon dioxide can dissolve certain kinds of rocks. They can also decay the natural cements that bind the particles of the rocks. Once the rocks are broken down, gravity helps them to find their way to rivers where they continue to break down even more into sand and gravel. Eventually, the sand and gravel find their way into lakes and oceans to be deposited. On the floor of the lake or ocean, these deposits start to form layers. Over a long period of time, these heavy layers build up and start to squeeze out any water. Once the water is gone, natural cement hardens and binds the layers in a sedimentary rock. The oldest layers are on the bottom and the youngest on the top. Let's visit our friend Roy to learn more about sedimentary rocks.
Now, sedimentary rocks are formed by the weathering, erosion, and breakdown of other rocks. That weathering, erosion, and breakdown of those rocks is what's responsible for the formation of the sedimentary rocks, one of which we can see behind us. Now, sedimentary rocks come in one of three types, one of which is called the clastic type of sedimentary rock. Clastic sedimentary rocks are formed by the accumulation of mud, sand, pebbles, and cobbles. This is an example of that type of rock. The other types of sedimentary rock are called biogenic or chemical. The biogenic and chemical form of sedimentary rock is formed by the accumulation of dissolved rock, usually underwater. Now, this example here of clastic rock occurred many millions of years ago when there was at one point a much larger mountain than you're seeing behind you at the present time. This mountain, which was behind us, was made of granite. And as that granite mountain eroded, large cobbles and boulders of granite accumulated at the base of the mountain at an angle. Interspersed with these cobbles and pebbles of granite were this red material, which is actually a red mud. As this material became buried, it underwent a process which we call lithification, turns the sedimentary material into a rock. These deposits that occur at the base of mountains are called alluvial fans. So these are an example of lithified or rock turned into rock alluvial fans. Later, subsequent to the burial formation of these, some tectonic or movements of the earth occurred, and these were lifted up to their current position.
Okay, now that we have learned how sedimentary rocks are formed, it's time for my friends to quiz you with some quick quiz questions. Don't forget to write down your answers so you can check how well you did at the end of the presentation.
Question 9. True or false? Sedimentary rocks are formed deep inside the mantle, where pressure and extreme heat can create them. Question 10. What type of weathering strikes at the structure or makeup of the rock? A. Mechanical, B. Physical, C. Chemical, or D. Psychological? Question 11. When sedimentary rocks are formed, the water is squeezed out by overwhelming weight. What hardens once the water is gone? A. Moss, B. Rust, C. Natural cement, or D. Plaque? Question 12. Rainwater and other substances like blank help break down the chemical makeup of rocks. A. Oxygen, B. Carbon monoxide, C. Carbon dioxide, or D. Nitrogen? Question 13. Which of these is not an element of mechanical weathering? A. Wind, B. Moving water, C. Air pollution, or D. ice. Question 14. What is a characteristic of a clastic rock? A. Accumulates ice, snow, and water. B. Is soft and fragile. C. Accumulates mud, sand, and pebbles. Or D. It has a wood texture to it.
How did you do? Did you write your answers down? Good. The final type of rock is called metamorphic rock. Metamorphic means change in form by pressure and heat. Deep down in the mantle, heat and pressure combine to change the form or structure of the rocks. Rocks react or mix with each other, forming new rocks. Igneous and sedimentary rocks can change to metamorphic rock through this process of heat and pressure. Even an existing metamorphic rock can undergo a change to another form by this metamorphic process.
Here we are in an excellent location where you can see examples of metamorphic rock, one of the three rock types in the rock cycle. Remember, the three rock types are igneous, sedimentary, and metamorphic. This rock I'm standing on is a very good example of metamorphic rock. These kinds of rock are formed when other rocks are subjected to heat and pressure, and they change, giving us the word metamorphic, which means meta, to change, and morph, form, change in form. There are two types of metamorphic rocks, one type called non-foliated and the other type called foliated. We give these rocks these names to indicate whether or not the rocks have got a grain in them, sort of like wood. Non-foliated rocks, metamorphic non-foliated rocks, do not have this type of grain in them, whereas foliated metamorphic rocks have a grain to them, sort of like wood. This is an excellent example of a foliated metamorphic rock. When you look at this rock, what you see is that inside the rock, the mineral grains themselves, due to the heat and pressure that's changed the rock, have aligned themselves in a particular direction, just like the grain of a piece of wood. This particular type of foliated metamorphic rock is called a gneiss.
It's that time once again. My friends are back and they have some quiz questions they want to ask you. Pay attention and don't forget to write down your answers. Good luck.
Question 15. Metamorphic rocks use blank and blank to change the structure of the rock. A. Water and wind. B. Pressure and heat. C. Heat and natural cement. Or D. Pressure and sunlight. Question 16. What characteristic is used to identify metamorphic rock? A. Size. B. Color. C. Wood grain texture. Or D. Parts of other rocks. Question 17. What makes a rock foliated? A. Crystals that are aligned. B. Crystals that are not aligned. C. Large crystals. Or D. Smooth surface.
All right, we have learned about the three types of rocks, igneous, sedimentary, and metamorphic. We can now see how the rock cycle works and incorporates these three types of rocks. New igneous rocks begin their formation deep in the earth. Eventually, they make their way as magma to the surface through uprising gases that are under pressure. These rocks are eventually exposed to weathering, which breaks them down into smaller size rocks. Once weathering breaks the rocks apart, they are pulled down slopes by gravity into rivers. Here they are transformed into mud, sand, and gravel, and eventually transported out to sea. Once in the ocean, the rocks are deposited into layers. As the layers build up over millions of years, the increased weight compresses the older layers. Water is then squeezed out by the pressure, and natural cement hardens to create sedimentary rock. As the earth moves or adjusts, these layers compress even more due to heat and pressure, eventually changing them into metamorphic rock. The deeper the rock is in the mantle, the more heat and pressure is applied, increasing the rate of metamorphism, or change. When the heat gets too extreme, rocks will melt and form molten magma. When magma surfaces and cools, it forms new igneous rocks, thus completing one cycle of the rock cycle. Rocks sometimes don't follow this cycle exactly. There are many different types of cycles within the rock cycle. For example, igneous rocks, especially plutonic or intrusive rocks, like granite, might be directly changed by heat and pressure instead of being eroded down into sedimentary rock. Or sedimentary rocks might be weathered down again and redeposited to make new sedimentary rock. Another path would be metamorphic rocks being pushed up to the surface and eroded away to make new sedimentary rocks. The rock cycle has many cycles they can go through, and no one cycle is more important than the other. It is simply a matter of chance on which cycle a rock will travel. My friends are back to give you the final set of the video quiz, so pay attention and write down your answers. Good luck.
Question 18. True or false? Rocks have only one way to go through the rock cycle, from igneous to sedimentary to metamorphic. Question 19. Why are oceans and rivers important to the rock cycle? A. To help clean rocks. B. To help the rocks break down into smaller rocks. C. To cool and harden rocks. Or D. To help bind the rocks into larger rocks. Question 20. True or false? Rocks can choose many routes through the rock cycle. No one cycle is more important than the other.
How'd you do? The next time you are exploring, try to figure out what type of rocks you are seeing. If the rocks have crystals, then there's a good chance it's an igneous rock. If the rock has many smaller rocks in its composition, then it's safe to say it's sedimentary rock. And if the rock has an appearance of the texture of wood, then it's probably metamorphic. Now that we have finished the quiz, you can check your answers with the answer key. Here come the answers. I hope you do well. Thanks for watching. See ya.
Question 1. D. The inner core is the part of the Earth's structure that is about the size of the moon. Question 2. C. The outer core is a sea of iron which produces a magnetic field around Earth. Question 3. B. The mantle makes up 70% of the Earth's structure. Question 4. D. The continental crust is located underneath the continents and is an average thickness of 22 miles. Question 5. B. The Latin root ignis means fire. Question 6. C. Pressurized gas is what helps the magma reach the surface. Question 7. False. The more pressure the gas is under, the more violent the eruption. Question 8. A. When igneous rocks cool underground, they form crystals. Question 9. False. Metamorphic rocks are formed deep inside the mantle, where pressure and extreme heat can create them. Question 10. A. Mechanical weathering strikes at the structure or makeup of the rock. Question 11. C. When sedimentary rocks are formed, the water is squeezed out by overwhelming weight. Natural cement hardens once the water is gone. Question 12. C. Rainwater and other substances like carbon dioxide help break down the chemical makeup of rocks. Question 13. C. Air pollution is not an element of mechanical weathering. Question 14. C. A characteristic of a clastic rock is that it accumulates mud, sand, and pebbles. Question 15. B. Metamorphic rocks use pressure and heat to change the structure of the rock. Question 16. C. Wood grain texture is used to identify metamorphic rock. Question 17. A. A foliated rock has crystals that are aligned. Question 18. False. Rocks have many ways to go through the rock cycle. Question 19. B. The oceans and rivers are important to the rock cycle because they help the rocks break down into smaller rocks. Question 20. True. Rocks can choose many routes through the rock cycle. No one cycle is more important than the other.